Good afternoon. So purpose of this live session is to discuss on the chapters that we have already finished. So 3 chapters have been covered so far. And you can post your questions if you have any doubts on these 3 chapters. And I'll try to clarify your doubts. Please post your questions in the chat box. I can see Mr. Basak attending the session. So if you have any specific queries on the topics covered so far, please post your query. We got some queries in the link shared with you earlier, but I have gone through these queries. All these queries are related to either the mode of conduct of exam or some other topics which is not directly part of the topics we have covered so far. So all these queries will send the replies by email. This time I want to utilize by answering your queries specifically on the topics that has been covered in the lectures. So now I could see one question, how microwave engineering subject is helpful in the field of communication engineering. When you say communication engineering, we have 2 types of communication, either wired communication or wireless communication. So the topics that are being taught in this particular course, it will help you understand both wired communication, how to model the transmission media, be it transmission line or waveguide or even optical fiber also, because optical fiber is a dielectric waveguide, or how to study the wireless communication. In the later part, we will discuss, there is a subtopic in the application of microwave engineering, we will discuss wireless communication. So radio communication takes place in the microwave frequency range, and the transmitters, the receivers, everything work in this frequency band, and therefore it is very important to understand the microwave principles properly to understand communication. Mr. Surjit Kumar, hello, good afternoon. So if you have any queries, you may post it in the chat box. I would request you to restrict the query to the topics which are being now covered in the lecture videos. If you have any outside query, you can send it over mail. We will respond to it. So any other query, please? Particularly on the topics that we have covered so far. Although the video lectures are available online, but in this program we are going in a sequential manner, and the first week we covered the introduction to microwave engineering, then transmission line. Then next we covered the waveguide concepts, Smith chart. So all these are very fundamental topics in the microwave engineering. And if you have any issues in understanding those concepts which has been discussed in the video, you may raise these issues in this live session. So I request you all once again to come up with your queries if you have any on the video lectures covered so far. Let us utilize this time, interaction time, in a fruitful manner. So a large number of learners are actually registered for this program. So I would request all of you, if you have any specific queries on the lecture material which have been covered so far, you can post your queries. So you have some query, Mr. Bashak, you have some query regarding the maxima and minima that is occurring on the transmission line. So for maxima or minima to occur, you have to have a forward traveling wave and a reflected wave, and when they interact you get a standing wave. Now the voltage maxima occurs, and after lambda by 4 distance you will have a voltage minima, and depending upon the nature of the load resistance and the characteristic impedance of the line, you will see its nature will vary. For example, if you have a purely short circuited transmission line or open circuited transmission line, then you will find that the voltage minima will become 0 and perfect standing wave you will get. If your load resistance is finite, then you will get maxima and minima occurring on the line. At the same time, power will be transferred to the load, so you will have a combination of both. Please refer to the video lecture. We have actually discussed in detail this issue. So you require two waves to be there. One is the forward traveling wave. You require a mismatch in the load so that part of the incident wave is reflected, and then these two waves they interfere and produce the standing wave pattern. So I hope I answered your queries. Yeah. Thank you for raising this issue. So I once again request you all who are attending this session live, if you have any other queries, please post your queries and utilize the time. So I will wait for a while, and if there are no more queries, then we will wind up this session. Why do we normalize the impedance while analyzing the scattering parameters? Yeah, scattering parameters, if you have a junction for which you have the port impedances, all the port impedances are same, then you do not require any normalization. You can directly write in terms of the S matrix, in terms of the incident and reflected voltages. But when you have a junction where you have each port having different impedances, characteristic impedances, then we normalize in such a way. If you remember, the power ultimately, if you consider an conjugate minus bn conjugate, that gives you the power going through the nth port. So normalization is necessary when you have the port impedances are different. When all the ports having the same characteristic impedance, then you really do not require that normalization. You can directly write in terms of V plus and V minus. The details again we have discussed in detail in the lecture videos. Please refer there. So any other question, please? So thank you, Mr. Bosak, for raising all these questions. Other participants who are attending this session, if they have any queries. So since there are not any other queries coming from other participants, I think we can close this discussion here itself. Thank you very much for attending, and particularly thanks to Mr. Bosak for asking the pertinent questions. Thank you.